This video focuses on reflections and symmetries. This first example is just an ordered pair 5, 3, and we want to reflect it about the x-axis and the y-axis and find out what would be the new ordered pair. So we have an ordered pair over 5, up 3, and here is our point. And let's talk about the x-axis first. Here's our x-axis, our horizontal axis, and imagine flipping it. That means like folding it along that blue line. Where would the ordered pair now be? It would flip to over 5 still, but now it would be down 3. Imagine taking this piece of paper and folding it, and it looks like that. So now our ordered pair is 5, -3. Now let's do the other reflection. Where would our ordered pair have reflected about the y-axis? So our y-axis is our vertical line. And imagine folding this piece of paper along this vertical line, and where would the ordered pair end up? Well, it's going to be -5 and then up 3. So imagine flipping it, and it ends up right here, -5, +3. The next thing I want to talk about is checking for symmetry. When you check for symmetry, you plug in a negative depending on what you're checking for. So if you're checking for x-axis symmetry, you replace the y with -y. And if you get the original equation back, then that's the symmetry you have, x-axis symmetry. To check for the y-axis, replace the x with -x. If you want to find out if you have origin symmetry, then you have to replace the x with -x and the y with -y. If you get your original equation back, then that is true for that type of symmetry. So let's go through an example. We have an equation, x squared minus y equals 0. And we want to test, does this equation, without graphing it, looking to see the symmetry, would it give us x-axis symmetry, y-axis symmetry, or the origin? So we'll test each individually. So here is our equation. So let's check for x-axis symmetry. So we replace the y in that purple equation with -y. So we say x squared minus, and now replace that y with a -y. Now let's simplify it. Well, we have a negative and a negative next to each other, so that becomes a plus. Now look at the blue and the purple equation. Are they exactly the same? No, they're not. So you do not have symmetry with the x-axis. Now let's move on to y-axis and test to see if we have y-axis symmetry. So we're going to replace the x with -x in the purple equation. So we say replace the x with -x. Well, -x times -x is positive x squared minus y equals 0. Did we get our original equation back from the purple and the blue? Yes. So we have y-axis symmetry. Now our last one is to check for the origin. Is there symmetry about the origin? So we're going to place the x and the y with negatives. And what we get, negative times the -x, is a positive x squared, and then negative becomes a positive y. We did not get the original back, so there is no symmetry about the origin. Now in this example, let's go ahead and graph this equation. Right now it's in what we call standard form. I'm going to go ahead and solve it for y. So I'm going to bring that -y to the left side. and then y equals x squared. I like to write my y first, then my x squared. Now let's just make a quick xy chart. We'll just plug in like 3 points. 0, 1, and 2. So we substitute 0 in for x. So 0 times 0 is 0. Plug in 1 in for x. 1 times 1 is 1. Plug in 2 in for x, and we get 4. Let's just graph those three order pairs first. So 0, 0, 1, 1, 2, 4. It looks like that. Now, we could continue finding more ordered pairs in the negative direction, or look at the symmetry. It has y-axis symmetry. So if here's my y-axis, and I imagine folding this piece of paper along here, I have to have an ordered pair on the other side that's symmetric. So I have to have a point here and a point there. So my complete function will look like this. And that's why it's important for us to know symmetry. It can save us some time down the road, give us some important pieces to the graphs. Our last example is another equation in the purple, x, y squared plus 10 equals 0. We want to check for symmetry. So this one will go a little faster. Replace the y with negative y. And I'll simplify it. Negative y times negative y is y squared. Did we get the original equation back? Yes, we did. So there is symmetry about the x-axis. So that's your horizontal axis you have symmetry with. Now let's check for x-axis or y-axis symmetry. So replace the x with negative x. And we just get negative x y squared plus 10. We did not get the original equation back, so there's no symmetry about the y-axis. And then our last one, replace the x and the y. With a negative. And you get negative x y squared plus 10, which is also a no. So there's no symmetry about the origin. We're going to use a graphing calculator to graph this function. So we want to solve this for y. So we would subtract 10 from both sides, and then divide both sides by x. And then the last thing is just to go ahead and square root it, so you get plus or minus the square root of negative 10 over x. And then just substitute this into your graphing calculator for plus and minus and see what you get. Do you get that symmetry that popped up?